So at the top of page 15 here was a statement to say that a tractor on a steep slope will topple over if a vertical line drawn from its centre of gravity falls outside the base area of the wheel. So for another example, they've asked us, what can a rugby player do to make herself or himself more stable in a ruck? And basically you would answer that question by saying bend her knees or his knees, depending on what way it's being asked, and have, okay, or so make a greater space between her feet and increase her base area and lower her centre of gravity. Okay, so that's the answer to that one. The next page, page 16, is about writing up a practical. So I just thought I'd go ahead and give you the theory on it, and when we get back into the lab we can do these practicals, okay? So before we leave the principle of moments, this would be a typical practical that you would either be asked on your paper or on your practical paper as well. So what we're being asked is we need to find the mass of a meter stick using the principle of moments. So the mass of a meter stick acts as its centre of mass at 50 centimetres. So if you have a meter stick, the centre of mass bang on the middle would be at 50 centimetres. If the meter stick is not pivoted at the centre, its mass acting at the 50 centimetre point will cause a moment on one side of the pivot. This is a bit like the ladders that we seen the builder carrying with a bucket of water. So this would be at 50 centimetres, but if there's a pivot here, then we would have to decide how we could balance that, because it wouldn't balance if we had a weight here with a short distance from the pivot compared to the longer distance right back to zero here. So the mass can be found by restoring the balance using 10-gram slotted masses, and they're placed on the other side of the pivot, and then we can apply the principle of moments with our calculations. So basically what you have is your meter stick. Here is the 50 centimetres, which is the centre of mass. But if there is a pivot, say if we were to drill a wee hole in here and attach it to the retort stand, this would be our pivot. And if we were to hang a mass here, and we would want to balance that, where would we need to position at what position do we need to put the mass to make it balanced? So we need to be able to look at our method. You're often asked how you would set this up, and this would be 6 marks on your paper, so it's always good to learn this. It is a prescribed practical. So we need to learn. Okay, so we need to place the pivot away from the midpoint of the ruler, okay, so that it's or the uniform object, a plank of wood or whatever, say at 20 centimetres. So that's point 1. Then we need to place the masses on the ruler, on the end of the ruler, until the ruler is balanced. You keep on slotting and adding 10 grams at a time or 100 grams at a time until you get this meter stick balanced. Once you've done that, at point 3, you record the distances from the pivot of the mass and the midpoint of the ruler. So if you had your ruler, your pivot is here, there's your midpoint. Say you had your mass here, and you had a mass here, then you would just measure the distances between the pivot and the 50 centimeter mark, and the pivot and whatever your mass was sitting at on the meter stick. So once you've done that, you would use the calculator to find out the mass of the ruler. Okay, now this again is just theory. So if you're asked this question, you just need to be able to explain how you would go about it, and they would give you the values. Okay, so it's important that you write down that this is what you would use. So force times distance equals force times distance. You would have an anti-clockwise and a clockwise movement, and then you would use the values that you found. And we'll just complete that on page 16.